So now that we know how to plot points, we're going to determine how to find the distance between 2 points and also the midpoint between 2 points. So first, distance. So let me remind you what the Pythagorean theorem says. It says that if I have a right triangle with legs A and B and hypotenuse C, then a squared plus b squared equals c squared. If we were going to take this and solve for c, we would take the square root of both sides. So c is the square root of a squared plus b squared. This is going to come into play later whenever we go to find the distance between 2 points. But for a right triangle, the hypotenuse can be solved for to get the square root of a squared plus b squared. So let's look at the point P is going to be x1, y1, and the point Q is going to be x2, y2. So let's say I go ahead and I plot these points. So let's say here's x1, here's y1, here's x2, here's y2. So here's my point P, here's my point Q. The distance I'm looking for is that distance. I'm trying to figure out if I go from P to Q, how far have I gone? So the way we're going to figure this out is to make a right triangle. So there's my right triangle. Here's my distance, let's call it D. Remember, for a right triangle, here's C, here's A and B. C was the square root of a squared plus b squared. So if we look at the triangle that we just drew, D, it's kind of like my C, is going to be the square root of my a squared and my b squared. I just have to figure out what is a and b. So let's start with a. So this distance here. If you kind of move this down to the x-axis, we see that the a is the distance between x1 and x2. So a squared is going to be x2 minus x1 squared. Now look at my b, trying to figure out this distance. Kind of move that over to the y-axis. That distance is going to be y2 minus y1. So I would square that. So the distance from P to Q is going to be the square root of the difference in my x's squared plus the difference in my y squared. So here's my distance. So for example, let's let P be 1, 3, and let's let Q be -2, -1. To find the distance from P to Q, we're going to use the formula we just had. Now you could graph these two, of course, and use the Pythagorean theorem, but we just kind of worked it all out, so there's no point in doing that again. Let's label this as my x1, y1. Here's my x2, y2. So the distance, remember it was x2 minus x1 squared plus y2 minus y1 squared. -2 minus 1 is -3. Square that to get 9. -1 minus 3 is -4. Square that to get 16. So I get the square root of 25, which is 5. So the distance from P to Q in this particular case is going to be 5. Now I know there are 2 square roots to 25, but if you think about this in a realistic form, we're talking about distance. Distance isn't negative, so the distance is always going to be the positive or the principal square root. Let's do one more distance formula here. Let's let P be 0, 8, and let's let Q be 1, -4. If I'm going to find the distance from P to Q, well, we're going to use our formula. Let's let this be x1, y1, and x2, y2. So I have x2 minus x1 squared plus y2 minus y1 squared. 1 minus 0 is 1, 1 squared is 1. -4 minus 8 is -12. -12 squared is 144, so I get the square root of 145. So now that we know about distance, let's talk about midpoint. So let's let P be x1, y1, and let's let Q be x2, y2. So let me just plot those here. So here, maybe here's x1, here's y1, here's x2, and here's y2. So there's my point P, there's my point Q. When we say midpoint, what we mean is we're trying to find the point that's in the very middle of the line segment connecting P and Q. So here's my line segment connecting P and Q. I'm looking for the point that's right there in the middle. So M, my midpoint, it's going to be a coordinate. I'm going to have an x-coordinate and a y-coordinate. Now how do we find those? Well, you're just going to average your x's and average your y's. So the x-coordinate for M, average your x's. The y-coordinate for M, average your y's. So for example, let's say that P is 2, 3, and let's say that Q is -4, 5. Let's find the midpoint connecting P and Q. So what's the point in the middle of the line segment connecting these 2 points? So remember, the midpoint is a point, so it's going to have an x and y coordinate. To find the x coordinate, take your x values and average them. So I have a 2 plus -4 divided by 2. For my y coordinate, take your y coordinates and average them. So this gives me 2 plus -4 is -2, divided by 2 is -1. 3 plus 5 is 8, divided by 2 gives me 4. So if we were to connect the points 2, 3 and -4, 5, the point that's right in the middle should be -1, 4. Let's do one more of these. Let's let P be -2, 0, and let's let Q be 4, 8. If I want the midpoint between P and Q, it's going to be a point. I'm going to average my x's and then average my y's. -2 plus 4 is a -2, divided by 2 gives me a -1, and then 8 divided by 2 gives me 4. So the midpoint is -1, 4. So at this point we have the distance from P to Q is the square root of x squared minus x1 squared plus y2 minus y1 squared. And the midpoint connecting the two is where I average my x's, average my y's. Now using these formulas, we can answer questions about given the midpoint, what's the other point, or given a certain distance, what other points satisfy a certain condition. So for example, let's say that the midpoint between P and Q is -1, 3. If P is 4, 6, what is Q? So I have that the midpoint between 2 points is -1, 3. So I'm going to write that down. My midpoint is -1, 3. I know that P is 4, 6. So this is kind of like my no column. I know everything over there. What do I want? I want to know what is Q. Well, Q is a point, so let's let it be xy. This is what I'm trying to get. I'm trying to solve for Q. Let's use what we know about midpoints. Remember, the midpoint between P and Q is going to be the average of the x's and then the average of the y's. So the midpoint, without looking at this, so ignore this for just a second, the midpoint is going to be 4 plus x over 2 and then 6 plus y over 2. So I took these 2 points and found their midpoint. Well, the problem actually gives you that. It says that it is in fact -1, 3. So that's where this m is coming into play. I'm trying to solve for x and y, So let's set each one of these equal. So I have 4 plus x over 2 is negative 1, and 6 plus y over 2 is 3. So I just set my two coordinates equal to each other. Looking at the first one, I'm going to solve for x by first multiplying by 2, and then subtracting 4. For my y, I'm going to multiply by 2, and then subtract 6. So q is negative 6, 0. So I've solved for q by using what the midpoint definition was. Let's say that I'm given the distance this time. So let's find all points that are 4 units away from Q. Let's say Q is 1, 2, with x coordinate 1. So I'm saying find all points that are 4 units away from the point Q equals 1, 2 with x coordinate 1. So let's write down what we know here. We know the distance between the points is going to be 4. That was this find all that are 4 units away. I know that Q is 1, 2. What we're looking for is we're looking for our P. But we know something about P. We know that P has x coordinate 1. So I'm looking for all the points that look like this. We'll ignore the distance for just a second. How do you find the distance between P and Q? Well, that would be the square root of x2 minus x1 squared plus y2 minus y1 squared. The problem tells you that distance is equal to 4. So all I did was find the distance between these two and then use this other piece of information to set it equal to 4. We'll now solve this for y. So let's see, underneath the radical I have 0 squared, so let's just go ahead and get rid of that. And I can square both sides. So I get y minus 2 squared is 16. Again, this went to 0. Take the square root of both sides. So I get y minus 2 is plus or minus 4. And then finally add 2. So I get y is plus or minus 2. So y is 6 or y is negative 2. So to answer the question, all the points that are 4 units away from Q equals 1, 2 with x coordinate 1, there are 2 of them. We'll say P1 is 1, 6 and P2 is 1, negative 2.